are in listen-only mode.
Hello, everyone. This is Terry Erzman. I'm the Vice President of Marketing for Citus Data. Thank you for joining us for today's webinar. Before we start, I'd like to make sure everyone can hear me. So if you could please raise your hand if you can hear me all right, I'd appreciate it. All right, see some hands going up. Very good, thank you. As we go along today, if you have questions, if you would please input them into the questions section of your GoToWebinar control panel. We'll answer as many of those as we can at the end of the webinar. And now I would like to turn the, today's webinar will be recorded. We'll send you a link to today's webinar recording as well as a link to the slides shortly after the webinar. So now I'd like to turn it over to Marco, who will present Scaling Postgres on Amazon Web Services. Marco?
Thanks. Hello, everyone. I'm Marco. I'm a software engineer at Citus Data. And I actually also used to be a software engineer on Amazon Web Services. So this brings the two together. So I'm going to talk about scaling Postgres on Amazon Web Services. And specifically, I'll be talking about two of our extensions that we built for Postgres that lets you scale it out across many machines. So one of them is CitusDB, which extends Postgres for doing kind of real-time analytics on very large data sets by running queries in parallel across a large number of nodes. And then PGShard, which is kind of an open source extension for sharding Postgres, which is more targeted towards NoSQL-like workloads. And it's kind of strange to talk about NoSQL-like workloads in a SQL database, but the idea is that all the queries have always specify some key, as in like inserts, well, by default, have some a specific value on the partition column, but then PGShard optimizes for cases where that value also appears in the where clause of select queries. And well, I'll get into more details later. And I want to kind of do a comparison, very high level, of like how CitusDB and PGShard, how they compare to existing AWS database services. And I think the bulk of this webinar is going to be demoing some different architectures, different setups on AWS, one where we deploy CitusDB on EC2 and query some very large data sets. And then we'll do another demo where we actually scale out Amazon RDS using PGShard. And I'll go into more details on those architectures. And then finally, if there's time, I have some benchmark numbers that we did for EC2. So what is CitusDB? I don't know if you're familiar with it, but it's kind of like PostgreSQL for big data, for large data sets. And the idea in CitusDB is that you set up a cluster with a master node and many worker nodes. And the master node will have a distributed table, which actually looks like a regular table. You can run queries on it as if it was a regular table. But the master node doesn't actually store any data. The data is stored in shards on the worker nodes. And the shards on the worker nodes are actually just regular Postgres tables. So essentially, this distributed events table, as you see in the picture, is chopped into many pieces, which are distributed across the worker nodes and are also replicated on the worker nodes in case one of the worker nodes fails. Now, when CitusDB gets a query on that distributed table, it kind of it has the metadata on where those shards are located, and then transforms that one query into actually many queries that it can run on the worker nodes that query just an individual shard, and it can run all those queries in parallel. And then it basically gathers the results of all those queries locally in a sort of temporary table, and then does a final query to produce the output of the query that the user actually ran. But to the user, this actually appears as a regular table where it does a regular query. Like the sharding is very transparent. And another advantage of having shards is that if the query contains some filters, like it only queries for a particular date range, and the master node knows that shards only contain data for a particular date, for example, it knows it only has to query maybe 30 shards instead of all the shards. And we'll show some examples of that later. And another advantage, I think, of CitusDB is that you can ingest very large volumes of data in parallel, kind of in real time. You can keep growing your distributed table without slowing anything down. And you can just keep adding more worker nodes. There's no real limit on the number of worker nodes. So this is very powerful, but what type of applications do you actually use this for? I think the most common application we see is sort of real-time analytics, where you have some large volume of data, usually logs, could be from event logs from your system, web logs, ad click streams, those types of data set, usually events, and you want to offer, or you want to build a dashboard where you can interactively sort of analyze this data. You can see graphs of like the traffic over the last 30 days or number of clicks or number of sales, but you also want to be able to change the time range or focus on a particular country. And so these translate quite naturally into SQL queries. But to actually produce the data for those SQL, or produce the results for those SQL queries, you need a very fast database that can analyze a very large amount of data very quickly. And so that's something that CitusDB is particularly good at. And also, compared to data warehouse solutions, which also are quite good at analytical queries, it can also support a large number of concurrent users. It can also support continuously adding new data or making updates. And it has basically Postgres's own indexing technology, so you can index it in any way you want. And the final advantage is, if you are familiar with Postgres, CitusDB is pretty much Postgres, so you don't really have to learn anything new if you start using CitusDB. So what is PG shard? Well, sometimes we get a bit of confusion about the difference between CitusDB and PG shard. Essentially, when we wanted to add inserts and updates and deletes to CitusDB, we decided to package it as a separate open source extension that people can use as a standalone product. But it was actually meant as just adding inserts, updates, and deletes to CitusDB. So it works. It does that quite well. But you can also use it by itself without having the analytical parallel query processing for just sharding tables across a large number of workers. And then in PG shard, you usually create a hash partition table. And in a hash partition table, when you get an insert for an event and this table has some sort of partition column, you look at the value in the partition column in the insert, take a hash of that, and then for each possible hash value, there is a particular shard that value has to go into. So for example, if we partition our table by, let's say, customer ID, we take the hash of the customer ID. Each shard will contain a particular range of integers, of hash values, and so the master knows where to send this insert. So PG shard works a bit like a routing layer. It just finds out which shard the insert has to go to and then forwards it to that shard. But when we do all these things, we also kind of try to do replication, because when you have a big cluster of worker nodes, it's quite likely that at any given time, one of them might fail. You don't want this to bring you down your whole cluster. So in the PG shard case, inserts would go to all the replicas. Now, as I said, this works quite well for what we call NoSQL-like workloads. And this is particularly a type of workload where the entire query can be handled within a particular shard. So if I do an insert on a particular customer ID for data for a particular customer, it goes to a particular shard. But then all my select queries also specify something like where customer ID is 5, and then I can send that to the same shard. And this is actually very similar to the type of, or conceptually very similar to the type of queries that you have in NoSQL databases like MongoDB, where often you write a value to a particular key, and then you read a value from that particular key. So those queries are very fast in PG shard, but then it's less optimized for queries across the whole database. But then PGShard kind of, you can install it on top of CitusDB, and then you can actually get both. So you get a mix. You can do NoSQL type workloads where you do inserts and selects on particular keys, but you also have parallel analytical queries that are quite fast. So you can get the best of both worlds. And very often, like when most people using PGShard are using it as part of CitusDB. Some people also use PGShard in production, like without CitusDB. It can be quite useful. So how do these things compare to AWS products that you might be more familiar with? An obvious one is like Amazon RDS offers PostgreSQL, but it is very much targeted at a single machine PostgreSQL. You can set up a streaming replica of your machine, but there's no real scale out, as in you cannot add more nodes. So CitusDB compares to that as in it serves more the OLAP use case, which is the online analytical processing, and the NoSQL use case where you scale out sort of a highly partitioned workload. But if you have an OLTP workload where you have a lot of tables with complex transactions between them, this is very hard to scale out. So this is more something you want to use RDS for. But then if you start running analytical queries on your single machine Postgres database, they might be very slow and take up a lot of CPUs. So in that case, you might want to scale out. Another advantage is like RDS has a sort of a fixed list of extensions that are installed, and you cannot really add new extensions. So in CitusDB, because it's pretty much in your control, you can add more extensions such as CStore, which does columnar storage and compression. So this can be a benefit. Compared to DynamoDB, so DynamoDB is kind of the NoSQL database from Amazon. So how does that compare to, well, CitusDB and PGShard? Well, DynamoDB is kind of like a high availability service, so you don't really have to think about keeping it running. It just is managed for you, and it stays on most of the time. And it's quite well integrated with other AWS services such as Kinesis and S3. Now, the advantage of CitusDB compared to that and PGShard is, well, one, lower storage cost. I mean, if you're talking about this scale where you actually need to scale out your NoSQL database, for example, like the storage cost is going to weigh in pretty heavily because in DynamoDB it's, I think, 250% more expensive than even Elastic Block Store, and then in CitusDB you can even just use the SSDs that come with EC2 instances, which are essentially free or at least part of the instance. So the storage cost is a lot lower, which matters a lot for big data sets. You also get more powerful querying, and you get more powerful indexes because you just get the expressiveness of SQL. And you can also do analytics in parallel, which is also not something you can easily do with DynamoDB. So you add more, basically you get more features and lower storage cost, but it's not, there's no managed CitusDB. Now the question we get most often is, how does CitusDB compare to Redshift, which is also an analytics? And Redshift is more in the kind of data warehouse space where it is very good at answering complex business intelligence queries very quickly in a few seconds. But it is not very good if you, let's say, as a backend of an application that you want to expose to users, to a lot of users or customers. Because I think there's a hard limit of about 20 users, but in any case, if there's a lot of queries in parallel, it slows down considerably. And also, it's not actually built for very interactive applications, which have to be responsive and respond in a few hundred milliseconds. It's more all queries take a certain amount of time. And then, so CitusDB is good if you want more users. Again, slightly lower hardware cost. Also, the ingestion layer, just being able to insert and update at a very high rate is not something Redshift is great at. And the other thing is with CitusDB, you get the latest version of Postgres. We always keep it in sync with the latest version. So Postgres 9.4, for example, has the JSON data type, which allows you to query JSON documents quite efficiently, which is not in Redshift because I think it's based on Postgres 8.3 or something. Just for completeness, SimpleDB, I think when I joined Amazon in 2008, SimpleDB was already dying, but it's still around. So SimpleDB is managed, so it's easy. You don't have to maintain any hardware, but it's kind of slow. It's eventually consistent. Doesn't really scale well. So I think most databases probably work better than SimpleDB. So what I want to do is set up like a little CitusDB cluster on EC2. I'm going to cheat a bit. I'm first going to show you how to set it up, and then I'm going to switch to a cluster which is already set up, because it would take some 10 minutes to actually create the cluster. And I'm going to create it using CloudFormation. So we have a CloudFormation template on our website. If you go to the download section, you can see the button. I'll actually show it to you. And that takes you to the CloudFormation console, and you walk through the form, and then 10 minutes later, you have a fully functional CitusDB cluster. And the thing it sets up is it sets up an EC2 instance for the CitusDB master node, and then an auto-scaling group of a size that you configure at the start. And the way it sets it up, the worker nodes use their SSDs in kind of a RAID setup. They also have an extra kind of space for staging data, but we're not going to use that in the demo. And the master node uses, doesn't store any data, but it has some metadata, and it stores that in Elastic Block Store in case you want to make backups of it. And there's a number of extensions pre-installed if you use this CloudFormation template. So I'm going to click this link, which will take us to the Citus Data website, where hopefully, if it's still working, and where I can click the CloudFormation cluster button. So this is the download page, very easy to find. And down here, there's options for different platforms, and here is the one for CloudFormation. So this takes me to the CloudFormation console. I can go to the next page. I usually want to give my cluster some unique name, pick an availability zone, and my key pair. I can pick like which instance types I want. Usually for the master, I pick a slightly smaller instance type, maybe M3 large or X large, because the master is not going to do a lot of work. The number crunching is done by the workers. So if I set up something like C3 4x large with 4 nodes, I think 4x large has 8 cores, so that will give me about 32 cores. And I can skip this screen, and I always need to check this box, and this is because the CloudFormation template gives your master node permission to talk to the auto-scaling group API to get the list of worker nodes. It's a very minor permission, but you need to check this box to give it. Then you click Create, and then you get to the auto-scaling, or sorry, the CloudFormation console, and you see it creating. And this will take about 10 minutes. It will go into Create Complete. I'm actually not going to let it complete. I'm actually going to delete it, because as you can see, I already have a cluster up and running. So this is one that's finished. And in the output section of my my CloudFormation stack, I can see the host name for the master. So I'm going to connect to this host name later. Sorry, but first let me just look at the EC2 console. So there's here are my EC2 instances, my master node, an M3X large, and worker nodes. And these worker nodes are in an auto-scaling group. So let me look at the auto-scaling console, because I want to do something later, but I have to prepare that a bit. I want to add a node to the cluster just to see how you do that. So I'm actually just going to increase the size of my auto-scaling group. And this will just cause a new instance to be created. You can see auto-scaling has figured out that there's too few instances. So in a few minutes, it's gonna add a new instance, and then later in the demo, I'll try to add this instance to the cluster. Okay, so let's actually connect to this master node. I'm actually already should be connected here. So if I log in, I'll usually see this banner. And I can just connect to the master node locally using PSQL if I'm on it. And I actually already created a table, and I loaded some data into this table. And I can show you the definition of the table. It's quite a, sorry. It has a lot of columns, and it's actually based on the Google GDELT dataset, which is a publicly available dataset containing basically metadata on news events. So it contains things like when did the event happen, who did it, was it like a government, whose government, and various pieces of metadata, how many times was it mentioned, this event in news media, where did the event happen, and finally, where is the URL where Google learned about this event. And you'll notice that if you're familiar with Create Table, there's a bit of extra text here which says distribute by append date added. And this is actually an instruction to CitusDB telling it that this is going to be a distributed table. And the partition column of this distributed table is going to be the date. And so every shard in this distributed table is going to contain some range of dates. I can also create indexes on this table, and when shards are created, these indexes are propagated to the shards. So to make this a bit more easier to understand, like I said on the master node has some metadata. So this is a kind of a view of that metadata. My metadata contains something about, these are the shard identifiers, and so this is kind of the name of the shard, and it contains a certain range of dates. So this is like the 2nd of January, and then there's another shard containing data for the 3rd of January, and these shards are placed on this node, and then there's another copy on that node. Now, the way these shards get added to the system is using the stage command. So the stage command, and actually there's actually multiple ways in which they can be added, but this is one of them. And the stage command is a bit like the Postgres copy command. And it takes a file, and that file essentially becomes a new shard in my table, and then it gets added to the metadata. So actually, let me just do a quick count query so we can see that data is going to be added. So right now, there's 51 million rows in my table. So I run the stage command. This is going to take about 5 seconds, and it's basically copying the file directly to the worker nodes. It doesn't really go through the master. The master doesn't do that much here. But two things happen here. One is that the worker nodes now have a new shard, and the other thing is that, and you can see like the size of the table is now bigger. The other thing is that the new shard is added to the metadata. So I now have this shard for the 1st of January, which was missing before. And let's take a look at the worker node to just get a good feeling for where, what this actually looks like. So I'm going to try to remember the name of my shard, 103451. So if I look at the worker node, I see there's actually a whole bunch of tables here with the names that I just saw. So and each worker contains a different set of tables. And the shard I just added is actually at the bottom here because it was the last one I added. So if I just quickly query this shard, okay, so this is data that's in the GDEL table, but this shard only contains data for the 1st of January. And so there's the date. And, well, some event, doesn't matter what. But if I query my table from the master node, I actually include all of the shards, and I kind of send queries out to the worker nodes to query the shards in parallel. Which allows me to query a very large amount of data quite quickly, because there's about 20 gigabytes in this table right now. So I can do kind of more analytical queries. So what this query will do is this kind of gives you a city name, And it counts the number of events per city in the last 30 days, where the country is the US, and then gives me the top 10 cities with the most events. And actually, let's turn on timing just to see. This is a reasonably fast query. So this might be something that shows up in a dashboard, probably in a different form, maybe not with news events and cities, but maybe your, the customers with the top 10 customers in terms of sales or anything like that. Other typical analytical queries are, gives me the number of events by day. So this could be very well be an input to a graph, to a chart, where the x-axis is the date, and then the y-axis is the number of events, like let's say number of sales, number of hits, number of clicks. So this is a very typical query for a dashboard to make, and CitusDB is fast enough to do that kind of very interactively in real time. And so you might wonder, like, how does this? Why is this important? How does this compare to, let's say, just normal Postgres? Well, I kind of wish I could show you, but if I ran this query or even just a count query on regular Postgres, I tried this morning, it took about 7 minutes. So, and here it takes 3 seconds, and the analytical query above would also take a few minutes if you did run it on regular Postgres. So that's really the difference between being able to make an overnight reporting application and being able to make an interactive user-facing application. Some other things I can do. So this actually searches the whole database for URLs containing the word Citus data. So we see there's actually one news event here about the upcoming PGConf Silicon Valley conference, and this goes through 20 gigabytes of data. Now, if you remember, there's one shard per day, and there's about 300 days in the year so far, because this contains data for 2015. And I have about 32 cores, so every core is doing quite a lot of work when I do this query. If I want to limit this amount of work, well, one thing I can do is say, let me add some filtering to the date. So I only want to search the month of July. Now the same query takes just 600 milliseconds, and it kind of makes sense because now it only, it has to search through much less data, but now there's a nice match where I'm going through about 31 days using 32 cores, so I'm basically answering this query as fast as I can. So like how you partition your data kind of matters a bit or matters a lot actually, in terms of whether certain queries run fast, and it also helps you speed up your queries. If you're partitioning by date, then querying certain smaller date ranges might actually have a big effect, or you could just add more cores to your system. You could scale out your system further. So let's also try that. I'm somewhat hopeful that my autoscaling has given me a new worker node. I should have 5 worker nodes now. Not 100% sure which one it is, but actually if you start CitusDB using this CloudFormation template, there's a little script that runs, that you can run called find workers. And CitusDB uses this pgworkerlist.conf. It's a very simple configuration file that tells the master node, these are your workers. And find workers just queries the autoscaling API to find those workers. So now I actually have 5 workers in here instead of 4. Now, that doesn't mean there's any data on that new worker yet. That new worker is completely empty. And also I need to tell CitusDB about this new worker. So I'm going to reload the configuration. And this is kind of the function that tells me, okay, now CitusDB knows that there are 5 workers. And that means that if there's new data, it could be placed on the new workers. But I still have my 20 gigabytes on 4 workers and nothing on the other one. So if I want to rebalance my data, I have a very simple function called rebalance table shard, which kind of goes through all the shards and tries to put the same amount of data or move data from the 4 existing nodes to the new one. to actually get a nice balance. So it kind of does this in a sort of, let's say, not very resource intensive way. So it's going to be take some time, but it's not going to interfere with your queries too much. If I go to a different window, I can still run queries on my table. I can also still add new data to my table. And the shard rebalancing shouldn't really interfere with my querying a lot. If I keep running this query, then maybe in 10 minutes or so, it will actually be getting a bit faster because then I have 5 nodes instead of 4. In the meantime, it might be a bit slower because there's some network traffic. But the nice thing here is there's no such thing as a maintenance mode or a read-only mode. I can just rebalance my data while new data is coming in and while I'm receiving queries. The opposite also works. If I remove a worker node, there's a different function called replicate table shards, because the problem with removing a node is then I lose replication. So now all my shards have 2 replicas. If I lose a node, some of them will only have 1 replica. So I need to re-replicate them. So there's another function for that. And it's quite easy to actually script these things. Like I just run find workers, reload the configuration, and then rebalance or replicate. I'm going to let this run. It's going to take some time because it's a fair amount of data to move around. And so if you have questions, put them in the box in the GoToMeeting, and we'll actually look at another demo, which is actually uses a very different architecture, but similar concepts. So for that, I'll briefly return to my slides. Return to full screen. And the second demo is kind of an experiment that we did a while back, and we were actually trying to answer a few questions at the same time. One of them, I told you PG shard is kind of the insert and update and delete layer for CitusDB, so it routes inserts to the right shard. But that creates a problem because now having a single master node becomes really a bottleneck. I mean, it's not necessarily a single point of failure because usually we set up, or people set up, let's say a streaming replica of the master node and with automatic failover. So that's not the biggest problem. But the big problem with doing inserts is that it becomes a bottleneck. So we looked at, can we actually make a masterless or a multi-master system where we can just have as many master nodes as we need to actually serve a certain ingestion rate. And the way we did that was by basically just taking the metadata on the PG shard masters, on one PG shard master, and then copying it over to the other ones, and having an auto-scaling group with containing the masters. And so this auto-scaling group can, you can add more masters, and they will copy the metadata from the existing masters. And we actually have a load balancer in front of our auto-scaling group. So you can now connect to your database via load balancer, do inserts and updates, and they will get routed to the right shards. Now, the other interesting thing about this demo is that when you're using PG shard and even to some extent CitusDB, you don't actually need anything special on the worker nodes. You don't need a special extension. You can just use any Postgres database because the master is just going to send regular SQL queries to the workers. So we could also use RDS instances, Amazon RDS, which is the managed database service, as worker nodes, which has some nice advantages that if you want to make backups or you want to do maintenance on your servers, RDS makes that a lot simpler than when you have to do that yourself, like if you want to increase the storage size of your servers, for example. So we also have a CloudFormation template to set this architecture up, and it's actually in a blog post. You can I recommend either just going to our blog or just searching for something like scaling out RDS PG shard, and you'll find it. So let me return to the EC2 console just briefly. You'll see that in addition to my cluster with 1 master and 5 workers, here I have the cluster with 4 PG shard masters, which was created by this CloudFormation template. And then there is also a load balancer for that cluster, which sits in front of those master nodes. And then on the RDS console, I see there are 4 RDS instances. So there's no nice auto-scaling feature for RDS, so the template always sets up 4 instances. You can pick which type of instance. If you want more, either you can just add them here, or you can modify the CloudFormation template. But I mean, it gives you a good starting point. So let's actually go to our masterless cluster. And here we're still moving shards. Okay, so I'm now connected actually to one of the PG shard masters. Doesn't matter too much which ones. There are no tables yet, so I am going to create those tables right now. And I'm first going to show you like just this is going to be local, like I'm logged into a master and I'm working on the local sort of Postgres server that's running on that master. And then after that, I'm actually going to go copy that metadata to the other masters. And at that point, I can use the load balancer. So first, I have to create the tables. I prepared some scripts which actually creates table, then calls master create distributed table, and then creates shards. So now I actually have a table. And the table I'm going to have is going to contain customer reviews. Let's say some retail website, people make reviews of products. And to show you the file I used, so the syntax for PG shard is slightly different from the CitusDB because it actually does a slightly different thing. So first I created a regular table for customers of customer reviews with a customer ID. I create an index on that table. And then I call this function master create distributed table with the table name and the partition column. And this tells PG shard, okay, this table is going to be partitioned by customer ID. And by default, PG shard uses hash partitioning, as I mentioned. So it's going to create a number of hash partitions. I'll show you the metadata in a bit so that becomes a bit more clear. And when you call master create worker shard, it actually connects to the workers and creates a shard or creates the actual table which is going to contain the data. So let me actually just show you the metadata. All right. What happened here is I'm connected to a different master node. Oh, that's interesting. No, I know what happened. Okay. So this is actually the PG shard metadata. And so it contains shard ID. This is the table identifier. And then I see these min value and max value. And so actually these ranges, they now cover the entire range of integers. So when PG shard gets an insert, it first looks at what is the value in the customer ID column, takes a hash, and then finds the range which this value falls into. And then sends it to that shard, and then there's another table containing shard placements. Sorry, my typing is a bit off. And that says, okay, this shard here. So actually, if I connect to that node, I should see, okay, there's a bunch of shard here. There's no data in my table yet, but so let's put some in. So now that I have, a distributed table that for any customer ID, I can pick a shard, I can easily do inserts. So if I insert into customer reviews, it goes into one of the shards. Actually, let's see how long that takes. Okay, it actually makes a round trip to RDS and then does the insert on there and then returns. So that's more or less the 1 millisecond. If I do a select star from reviews, like this is the type of query I really like for PG shard where there is a customer ID filter specified. And so this query is always going to be quite fast. And even if you scale out your system to very to be very large, this query is still going to be fast. And I can also do updates. So now all the review ratings went from 1 to 5. Of course, I can also do deletes. And what the other thing I can show is like this CloudFormation template comes with a script which actually synchronizes the metadata on, I did that wrong. Okay, this script synchronizes the metadata to all the other master node. And I can now actually just connect to the load balancer. So I'm changing my host to the load balancer. It probably already was set to the load balancer, which is why this didn't work. So if I now run PSQL, I can see, oh, I'm actually connected to masterlist.elb.amazon AWS. So you can still see my table. I can do inserts on my table again. I can do selects. There's still only one item in my table. So I can also just put some more data into my table. So this is actually using a command that comes with pgshard to quickly insert a lot of data into the table, and then actually uses a lot of, like, 128 connections, because the load balancer can take a lot of different connections. So this is going to take maybe about 15 seconds to ingest a few 100,000 rows into my table. So that gives us a bit more data to work with. Okay. So I can now actually also run analytical queries on my table, because well, I actually also have CitusDB on this node. So if I only had PGShard and not CitusDB, this query would be kind of slow, because it would start querying the shards one by one. But with CitusDB, it does them in parallel, so they're usually quite fast. Another thing that's kind of interesting to show is, given the fact that we have a load balancer and a bunch of master nodes, I can look at okay, which node am I connected to, and let's actually just kill that node and see what happens. I think it's this one, so let's kill that node. Okay, so let's run our query from before again. Okay, actually that didn't work. The connection closed unexpectedly because I terminated the node. But then PSQL reconnected the load balancer, and now I can run my query again. So I just lost one of my databases, but I didn't really care, because there were others in my autoscaling group. And my RDS instances, they are kind of set up for multi-AZ. So if an RDS node fails, it kind of does its own failover. So I have a highly fault-tolerant, pretty high availability setup with this combination, and I can scale it out to be, arbitrarily large, because I can keep adding more master nodes to make sure I don't have an insert bottleneck, and I can also add more RDS nodes and rebalance the shards. So that concludes this part of the demo. So let's just go back to the slides for a bit. Now the final part I want to show, and these numbers are a bit older, but it takes a lot of time to do proper benchmarks. So I think the numbers are still somewhat relevant, even though we did them on slightly older versions of each of our software, which is now 4.1, and also Impala and SparkSQL. So this was a TPCH benchmark with about 1 terabyte of data across 20 R3 fork large EC2 instances. And here the entire 1 terabyte more or less fits in memory. And then TPCH is a data warehousing benchmark, which has some complex business intelligence queries. So it makes databases work really hard, basically. And this is just to get you a sort of feeling for how it compares to systems like Hadoop-based systems like Impala and SparkSQL, where in most cases CitusDB is slightly faster or a lot faster. In some cases, Impala is actually a bit faster. Now, these are not the sweet spot for any of these systems. Like TPCH is the sweet spot for data warehouses like Redshift. But I think it's a reasonably fair comparison of these systems that we did. We did know this with SparkSQL, and again, there have been more recent versions, but the really complex join queries, you can do join queries with CitusDB, but with SparkSQL, sometimes the intermediate results get so big that they don't fit in its cache. and it starts dropping results, intermediate results that it needs later. So we had a lot of trouble actually running some of these queries, partly because like Spark is purely in memory and it doesn't really flush to disk, and whereas Impala and CitusDB do. We also have numbers for like when you use SSDs, so this is a much smaller cluster with only 4 nodes, so the data doesn't fit in memory. Again, in a lot of cases, CitusDB is faster. There's a few where it's slower, but overall it compares quite favorably to these systems. So these are the benchmark numbers. So to summarize, we've looked at an introduction of CitusDB. It's a database especially well suited for real-time analytics on large amount of data that is being updated in real time. And then there is PG-Shard, which serves the NoSQL use case where you need to scale out your database across multiple machines, but then your queries are kind of have a certain specific characteristics, as in they can be easily run on a single shard. And it's very easy to get started with these systems if you're familiar with AWS. Just launch a CloudFormation cluster, and it'll take 10 minutes, and it'll be up and running. Now, CloudFormation has some limitations where it's not so easy to do optional features. So we actually have some more CloudFormation templates that we haven't published, and if people ask us about it, we can share them. Like if you want to launch CitusDB in a VPC, want to use placement groups, we also have one that kind of does automatic failover of the master node and puts it in the replicas of the master node in different AZs, so you have some more better availability. Or if you want to use Elastic Block Store on the worker nodes, we know it doesn't perform as well, but then you might want to make backups. So it could help you for that, or maybe you want a terabyte of storage. So we have templates for that. So if you need those, just ask us about them. So with that, there's about 10 minutes, 15 minutes left for questions. So over to Terry.
Okay, thank you, Marco. Just quickly before we go into the questions, Marco mentioned PGConf Silicon Valley. For those of you in the San Francisco Bay Area, that event is November 17th through 18th at the South San Francisco Conference Center. So please look it up if you would like more information at pgconfsv.com. Okay, first question is, can we independently set up streaming replication on individual shards?
No, I mean streaming replication, the way it works in Postgres is it is a copy of your entire database. Like your database has a write-ahead log, and every transaction in the database goes into that log. And streaming replication is basically just copying over the log from one database to another, more or less. There is actually some work done recently in Postgres called unidirectional replication and also bidirectional replication, which does actually allow you to do that. Now, unidirectional replication is actually available as an extension for, I think, Postgres 9.5. So you should be able to use that because you don't need the worker nodes to be Postgres 9.4 or anything. It can be any version. So you should be able to use UDR. The thing is, like, it might not necessarily work well, for example, with PG-Shard, because PG-Shard will look at it. If it knows that there are 2 copies of a shard, then if it does an insert, it tries to do the insert on both copies of the shard. So, like, if you do UDR on top of that, that probably will not work nicely, because then I expect that UDR will also try to replicate one of the inserts to the other, so then the secondary replica placement will have the insert twice. I think that's how it works. I'm not sure. But like what you can do is, like, you can set up, if you use streaming replication, you can set up a secondary for your worker nodes, so then you don't need to use like PG-Shard's built-in replication. There are some advantages to having secondaries, but you will need to somehow make them fail over automatically. Yeah, and actually, like in the next version of PG Shard, we might actually move towards that architecture a bit more because we find it's actually easier to scale that out. If the master is actually responsible for replication by sending inserts to all the replicas, that is a bit harder to scale out because then the master needs to keep track of, okay, if an insert failed on one replica, I can no longer use that replica, but now if there are multiple masters, they don't know about that yet. So we actually are going to towards a architecture where the replication is more being done on the worker.
Oh, and a related question is internal replication based on streaming replication?
No, so right now it's based on just replicating the statement. So if you get an insert, it goes to both replicas. Like the advantage of doing that is that if they're, let's say if you have a worker node failure and you're doing a select and then the worker node that you are running the select on is temporarily unavailable, it's very easy for PG Shard to say, okay, I'm just going to run the select on this other node, the other placement. So it makes it quite fault tolerant. If you add streaming replication, it becomes a bit trickier because the secondary might be a bit behind. So you cannot as easily fail over the selects. So that's one of the advantages of doing statement-based replication. But the drawback is that, well, if you want to keep certain, like you can kind of configure how much consistency you really want out of PG Shard. If you want your, like if you have updates that are not commutative and that cannot be applied in different orders, for example, then PG Shard will have to do locking on the master node of the shard, which makes the concurrency quite bad. So you want to avoid that situation. So that's a drawback of the statement-based replication. And I think that drawback is also why future versions of PG Shard will move towards using streaming replication on the workers.
Next question, how does CitusDB compare to Greenplum?
I'm not super familiar with Greenplum. I believe it to be also more in the data warehousing space. But I can't really, I don't have performance numbers and I haven't worked with Greenplum. Certainly it's like it's also in, like at least current versions of Greenplum kind of have the drawback that it's, that they're quite far behind in terms of the Postgres version, whereas CitusDB always just keeps up with the latest Postgres version. And yeah, again, like you get a lot of nice features out of recent Postgres versions, which you can use with CitusDB, such as JSONB and new types of indexes. So yeah, I can comment on that. I haven't tried using Greenplum, so I can't say too much about it.
Okay, I'll expand on it just a little bit. As you mentioned, Greenplum's on an older version of Postgres. I think it's 8.3. But also, CitusDB is kind of an operational analytics database, so it's for your real-time data, whereas Greenplum is more of a data warehouse, so it's for delayed data, essentially running larger or longer-running queries on older data. Next question is, what about joins across the distributed tables?
Yeah, those are possible. Like they're always they're a bit tricky. Let's say. I mean, you can run joins on distributed tables, but for them to be fast, you kind of want to make sure that your tables are co-partitioned. So they are partitioned by the same key, and then the data that will be joined together is already on the same host. So a lot of CitusDB users that want to use joins kind of try to make sure that all the data is that is actually joined in the same place. If that's not the case, it's not the end of the world. What CitusDB will do is it will take one table and repartition it to match the other ones so that it can apply the join it can join the shards pair by pair by pair. Basically, that's what it ends up doing. But this repartitioning operation is quite expensive, so it takes away, it takes a few seconds usually, at least. So it takes away from the sort of real timeness of it. But if you can make sure that your tables are co-partitioned, joins can be very, very fast. So yeah, there's a story there. But I mean, the short answer is yes, you can do joins. Just make sure that you think about like how data is laid out in the cluster.
Next question is, AWS Postgres has a 6 terabyte limit. What is the limit for CitusDB?
There is no real limit, since you can always add more hosts, and there's no limit to the number of hosts. I'm thinking like what the limit on EBS is. I think it used to be 1 terabyte, and then you can have a certain number of volumes on an instance. So perhaps per host it might end up being something similar, but you can have as many worker nodes as you want. Like if you want 100 worker nodes, you can have 100 worker nodes. So there are CitusDB deployments with let's say far more data than that. So because you can scale horizontally, there's no real limit.
Is it possible to have multiple replicas?
Yeah, so I kind of maybe mentioned that there's like 2 replicas. Actually, that's just a configuration parameter. So you can have any number of replicas, and especially for larger scale systems, you might want to have more. Like if you have 100 nodes, it gets quite likely that 2 or 3 nodes might be down at any given time. So then you might want to have a slightly higher replication factor than 2. I think 2 is an easy number, but it's a configurable parameter.
Okay. How do we upgrade Postgres to say 9.5 in a sharded scenario?
Well, it's quite easy to take down, like say, a worker node, upgrade it and bring it back, and then on the machine you basically run PG upgrade, or you just throw away the machine, add a new one, and then re-replicate. That's probably actually the easiest thing to do when you're running an EC2. Just terminate the old machine and get a new one. For the master node, you mostly want to copy over the metadata from the old machine into the new machine. I'm not sure if it's even worth going through a PG upgrade procedure. You can probably just copy over, use copy to get the metadata out and put it into the new database. So yeah, because you can take down any worker node at any time, basically, as long as you don't take out more than a certain number. It gets quite easy to make those kind of upgrade changes. And actually, with the current cluster that's up and running, you saw maybe that in the CloudFormation console it said update complete, and that the change I made is I switched to a different instance type. So I actually I changed the instance types of all the worker nodes at some point before the webinar, and so it's quite easy to do that. Like just terminate one and then add a new one and then rebalance or re-replicate the data.
Okay, final question we have time for, I think. How does it rebalance? Does it move data from each of the existing shards into the new shard?
Yeah, so it moves things shard by shard. So it doesn't actually split up existing shards, but it looks at the sizes of the shards on each node and then picks a few that it's going to copy into the new host. And so there's some functions that are like on the worker nodes. They either come as part of the extension, or we also have some like SQL versions of those functions, which you can run on any Postgres node. And that function basically connects to another worker node and then copies the data directly from there. So the data flows directly between workers. Now, while this is happening, if you do inserts on the shard that's being moved, they kind of block. So But usually you want to make sure that your shards are not massive, like not terabytes, maybe a gigabyte, such that it only takes seconds to move over the network, and then inserts can continue if you're doing inserts. If you're just doing this more like bulk loading use case where you just keep staging new shards and then you never actually change the old ones, of course you don't really have a problem.
Okay, thank you, Marco. So that concludes today's webinar. We did record the session, and we will send a link for the webinar recording as well as the slides. And there were a few additional questions which we didn't have time to address, which we'll pass to Marco for potentially using as the basis for a short blog post to answer the rest of the questions. Thank you everyone for attending, and please check our webinars page for upcoming sessions. Thank you.
Thanks.